Hi scholars, we are doing an online video on simplifying radicals. Now the reason why we're doing this in the middle of chapter 7 is that when we get to chapter 8, we work with the square root symbol all the time and simplifying radicals, and so we need to make sure that we're ready for it, and so we're reviewing your Algebra 1 skills in order to make sure we're at that place. So first things first, on your notes you probably saw that it was totally blank for your perfect square numbers. So you had all the way from 1 squared to 20 squared, and I filled them all in here for you. But I want to add a little bit more on your perfect square numbers. I want to remind you about when we multiply variables. So like when you multiply x times x, you get x squared, and x squared is a perfect square number. Or if I go x squared times x squared, I get x to the fourth. So x to the fourth is also considered a perfect square. And it keeps on going down the line. You can go like y cubed times y cubed. Well, that's y to the sixth. So even number exponents are also considered perfect square numbers. So just kind of keep that in mind because we'll be using that in just a little bit about simplifying radicals. So first things first, I want to talk to you a little bit about different ways of simplifying radicals, because honestly I'm going to use the fastest method, but I'm really good at simplifying radicals. I've been doing this for a very long time, but you guys can do it really well too. So I'm going to show you two methods, and then after that I'm just going to use the fastest one, but you can use either method as long as it helps you get the right answer. I'm just warning you, when you get to higher level math, you just got to be quick as possible. So first things first, we're going to remember simplifying a square root is to factor out basically all perfect square numbers and then take the square root of them. So we're going to start real quick with just square root of 8. And so the first method, we're just going to call it method 1, and I'm going to call it the fast method, is actually using the idea of factors of a number. And I'm going to always take out the largest perfect square factor. So the first thing is I rewrite the square root of 8 as if I was multiplying two radicals together to get it. Now 8 is not a perfect square number, so I look for a number that is a factor of 8 that's perfect square, and the one that's most common would be 4. So what's the square root of 4? Well, that's 2. And then after you take the square root of it, the radical sign goes away and you get 2 times the square root of 2. So the square root of 8 equals 2 root 2. Now that was pretty fast. Now the other way, method 2, is using the idea of prime factorization. So if I have the square root of 8, I break it down to its prime factorization, which is going to be 2 times 2 times 2. Well, the idea of taking the square root is I'm looking for pairs of numbers multiplied by itself, and I get one pair of 2's. So when I take the square root of that, I take one of those pairs out. So it becomes a 2, and it's 2 root 2. Now I jokingly tell people when I used to teach this way back when, the square root symbol is like a wedding chapel, and then when you have a couple, a pair, 2 become 1, so it comes outside the wedding chapel because you get married and it comes out, and then what's left is the old maid. It's not the best, it's a bad joke, but it works pretty well on understanding how to simplify radicals. So that's pretty easy. Most of you can do that. A lot of times if you can simplify radicals in your head, your teachers just love it, because the less work you have to show, the better. So I'm going to show you method, let's write that up above actually. Let's method 2 again. Now this time with a little bit harder number to simplify. Again, this is not a perfect square number. However, I'm going to look for the largest perfect square number that comes out of 98. Well, I'm really used to looking for these type of numbers, and so I know that's 49. And someone goes like, how did I get that? Well, I know 98 was even, so I just divided by 2 and see what happened. And I got 49. So then I take the square root of 49, which is 7. And notice I wrote it as negative 2 times 7, and I get negative 14 root 2. Now, if you're really good, a lot of people can go from the very first, the problem, to the answer. Most people, though, probably are a little bit better about going to right here. And then we get negative 14 root 2. So I don't really care which way you get there. I went to the point where actually you do it in your head, which would be wonderful, but make sure that you're able to simplify it real well. Well, how about, that should have been method 1, sorry guys. Method 2, where I'm using the prime factorization. Now remember, prime factorization is like when you were doing a factor tree as a kid. So you had 2 times 49, and then we keep simplifying it until we only have prime numbers left. So if I had a -2 square root of 98, I'd rewrite that as -2 times the square root of 2 times 7 times 7. Well, I have a pair of 7s, so I know I have a perfect square number I can pull out. And so that's really 49. Square root of 49 is 7. So I pull out the 7. So again, -2 times 7 root 2. So that gives me a -14 root 2. Again, it didn't take that long because it's a smaller number. It's just when numbers get really big, that's really hard. So now I'm actually changing my pen color to black because I'm going to use the fastest method possible. And I'm looking to simplify quickly. So when I look at the square root of 32, because I'm so used to doing radicals, I already know that's 4 root 2. But for a lot of you, just think about what's the largest perfect square number you can pull out. And remember, all your perfect square numbers are right here. Well, here's a hint. Look for anything below 32. So it'd be these numbers. Well, which one of those works into 32 really well? Yeah, 16. And so that's how I know which one to pull out. So I go 16, and then the perfect square number on the right is the one that's not a perfect square. I go the square root of 16, well that's 4 root 2, completely simplified. Doing the same type of process, again, I'm going to use method 1, which is the fastest way of doing this. I'm going to look for perfect square numbers. Now the thing is, you always have to double check your final answer to make sure that you also have a perfect square number, that you've always got in the simplest form, because sometimes you won't get there. But I know 54, I get 9 and 6. So 6 is not a perfect square, but 9 is. Well, the square root of 9 is 3, and I get root 6. It's not that bad, is it? I know. It's pretty simple after a while. All right, so how about this next one? I get 5 times the square root of 125. Well, I'm going to rewrite this again because 125 is not a perfect square number. And I want to think about what perfect square number comes out of 125. Well, the nice thing is if you kind of think of like in money, you know, quarters come out of 125, right? You get 25. So I get 25 in one of my radicals, and I get root 5 in the other. So I get square root of 25 times 5. Well, what's the square root of 25? 5. Well, 5 times 5, my friends, 25 root 5. And again, a lot of you will get to the point eventually where you can do that quickly in your head, or you already can, which is pretty cool. So the next one, I get a -10 times the square root of 300, and I want to look for the largest perfect square. Now, some of you said, well, you can take 25. Well, if you take 25, you also get the fact that like this is like 12. Well, 12 actually has a perfect square number that can come out of it, 4, so that's not the largest one you can take. So instead, always think largest perfect square number, and that's going to be 100. And then what's left over is 3, because 3 times 100 is 300. So again, -10 times the square root of 100 is 10 root 3. So again, -100 root 3. Excuse me. All right, let's keep going. Now, what happens if I have two radicals being multiplied together? Well, here's the thing. You multiply the numbers underneath together and the numbers out front together. So this actually becomes 324. Now, here's the cool thing. The square root of 324 is a perfect square number. Now, it's because I have these memorized. It's pretty quick. But if you go back up here, oh, look. Square root of 324 is going to be what? Yep, 18. So after I multiplied together, it actually made it a perfect square number. So that was pretty cool. Now we're going to talk about those lovely exponents and those perfect square numbers we talked about earlier. Here's the deal. I am still looking for perfect square numbers, but here's some stuff that you need to think about. Remember, if it's an even exponent, it's a perfect square. If it's an odd exponent, we can easily factor out a perfect square number. Because do you guys agree with me, if I get y to the 5th, that's the same thing as y to the 4th times y to the 1st. And y to the 4th ends up being a perfect square. So that's how we're going to use factoring to help us out here. So just like before, I'm going to have my two radicals. My radical in the middle, 3 times the square root, those are my perfect square numbers. So I look at 8 first. Well, what's the perfect square number that comes out of 8? Well, that's 4, but 2 remains. Then I look at x times the square root of 4. Well, that's an even exponent, so that is a perfect square number, so it comes out. Then I get y to the 5th. If it's an odd number and it's not y to the 1st, all you have to do is go one less. So I get y to the 4th, and then y is left over. Because remember, y to the 4th times y to the 1st is y to the 5th. Then I'm going to take my square roots. So I get 3 times, well, what's the square root of 4? Well, that's 2. The square root of x to the 4th is going to be x squared, because x squared times x squared is x to the 4th. Square root of y to the 4th is y squared. And then I get times the square root of 2y. And then I multiply things together. I get 6 x squared y squared times the square root of 2y. Okay. All right. So then we get our next numbers. And that's it. That's how easy it is to work with exponents, guys. So hopefully this is making a little bit of sense and it's jarring your memory from last year. But if you're struggling with this, this is one of the things you come to lunch on Monday to get help. Or you come to lunch on like Friday if you have 4A lunch, or you know, sometimes a scenario like that. Let's get this done as soon as possible. I want to make sure you guys understand this before we go into chapter 8. But let's try the next one. Again, I'm going to look at it and see if I can find my perfect square numbers. Well, I look at 72. Well, the largest perfect square number that comes out of 72 is 36, but 2 remains. I have x to the 7th. That's an odd, but that's okay. I can just take 1 away from 7 and get x to the 6th, and that leaves an x here. Then I have y to the 8th. Okay? So now we get the square root of 36 is 6. X to the 6th, the square root of that is x cubed. Square root of y to the 8th is y to the 4th. Root 2x. Well, what's 5 times 6? That's 30. X times x cubed is x to the 4th. And I need to move that down a little bit, don't I? 30 x to the 4th, y to the 4th, and then you just bring your radical down with what remains. That's not perfect square numbers, so it'd be square root of 2x. Simple as that. Let's try another one. So I got negative 6x. And I'm looking at it and I'm like, ooh, nice thing is 144 is a perfect square number. So let's just go ahead and put it in here just to make it a little bit easier. X to the 6th. What's really nice about x to the 6th, it's a perfect square, so it can come out. Y to the 9th is not a perfect square, but y to the 8th is a factor of y to the 9th. So then we get y to the 1st stays there. Then I get z cubed. Well, I can take a z squared out, and then a z is left. Let's see if I can write it down without having issues here, and I keep wanting to cough. So sorry, guys. And now let's simplify it. So I get negative 6x. Well, what's the square root of 144? Well, that's 12. The square root of x to the 6th is x cubed. Remember, it's just half of the 6. Square root of y to the 8th is y to the 4th. Square root of z squared is z times the square root of yz. Now we combine like terms. So I get negative 72 x to the 4th, y to the 4th, z times the square root of yz. Kind of complicated, but easy to simplify perfect square numbers. All right. So hopefully this has jarred memory. I would rewatch this. I would go find YouTube videos online. Those of you who had Mr. McDonald, he has a great video link on how to simplify radicals. It would be a great memory jar. You guys can do this pretty well. But now we're going to go on to this using what we just did, and we're going to add in subtract radicals now. All right, so to add or subtract radicals, you have to know, number one thing is you must first simplify each term before adding or subtracting, and then one adds and subtracts the coefficients, not the numbers underneath the radicals. So first of all, it'd be something like this. So here's an example. What if I had something like this? The square root of 8 plus 3 root 2. Now, since the 8 and 2 are underneath the radical and they're not the same, I cannot add them together. But I can simplify the square root of 8. Well, that ends up being square root of 4, root 2, 3 root 2 stays around. And I get, oh yeah, square root of 4 is 2, so that's 2 root 2 plus 3 root 2. And then you treat your radicals right here. The square root of 2 basically is almost treated like a variable. So think about like what you had before when you had variables. You'd sit there and go 3x plus 2x, you would tell me is what? 5x. Well, do the same type of idea when you're working with radicals. So I add the coefficients. So what's 2 plus 3? Well, that's 5. And that's root 2. So my simplest form of root 8 plus 3 root 2 is actually 5 root 2. And let's do another example of this. You could have something as simple as, let's go, how about 3 root 3 plus 5 root 2? Now, do I have to simplify those radicals anymore? No. Okay. So then I look at the radicals. Root 3, square root of 3, and the square root of 2. So, by the way, if you haven't noticed, the slang way of saying square root is root. So root 3, root 2. They're not the same. So guess what? You can't add them. You just can't. You're done. Voila. You're finished. You can't add, okay? If you had something like this, if you had 4 plus, let's say 5 root 3. You can't add those because 4 does not have a root 3 after it. They're not like terms, so I can't simplify any further. All right, so on example 2, it says you can only add or subtract radicals that are the same. So actually, I've been really kind of doing that already in the first one. Let's have a little bit of fun here. Let's go the square root of 27 plus the square root of, let's go 75. Well, let's simplify each one of these first because that's step 1, right? Before I can do anything, I have to simplify them first. So I get square root of 9 times square root of 3 plus then I get square root of 25 plus the square root of 3. So I get 3 root 3 plus 5 root 3. Well, my radicals are now the same because remember these are totally staying the same. And then what do I get? I get 8 times the square root of 3 because 3 plus 5 add. Pretty easy. Schmeezy. Nice. Not a big deal. Now we can, I notice I haven't any subtraction signs, but so what? You can totally do stuff with subtraction signs. Like you might have something like this. 3 times the square root of, let's go 32, plus, let's just do subtraction again. Minus 5, let's think of the square root of, good, hard question, good one to think about here. Let's go 128. Okay, well, to simplify that, I take out my perfect square numbers, and my perfect square number that comes out of 128 is 64. So notice square root of 32 goes into root 16 root 2, square root of 128, square root of 64, 2. So then I get negative 3 times 4 times root 2 minus 5 times square root of 8 root 2. I get negative 12 times the square root of 2 minus 40 times the square root of 2. And then we can simplify it like terms. Since they're both negative, we add them together. I get a negative 52 root 2. Now, I warn you right now, if you're looking at the filled in notes online, I totally use different numbers. I just totally made these off the top of my head. But the same point comes across. Make sure the radicals are the same before you can add them. If not, you just have to simplify each radical and then leave it in that form, like I just showed you with the arrow there. Guys, make sure you just take it step by step. Now, I have tons of examples here, so I overkilled on examples on these notes. Bear with me. I just think we need to see them and feel pretty confident in ourselves. All right, so I think I've got, yeah, like 6 examples here. So let's just crank this out and see what we get. All right, so let's simplify. 3 times the square root of 8. So I get 3 times the square root of 4 times the square root of 2. 4 root 2 doesn't need to be simplified. Well, guys, what's the square root of 4? 2. Well, let's do that now in our heads. 2 times 3 is what? 6. So that's 6 root 3 plus 4 root 2. Guys, oops, excuse me, where I said 6 root 3, excuse me. 6 root 2. Add those together. 10 times the square root of 2. Voila! Perfection. You know, right? So simple, so much fun. I love working with radicals, especially if I'm half awake, so that way I don't make any silly errors like I just did. Let's try the next one. The square root of 25 times the square root of 3, right? Square root of 75 can simplify out. What can simplify out of 27? Oh, that's the square root of 9 times the square root of 3. Now let's do this in our head. Let's start speeding this up so we don't have to write every step down. What's the square root of 25? Well, that's 5. So that's 5 root 3. Well, what's the square root of 9? All right, that's 3. So 3 times 5 would be 15. root 3. So 5 root 3 minus 15 root 3 is what, my friends? A negative 10 root 3. All right, let's see if we can keep cranking these out really fast. All right, for the next one, I get 6 times the square root of 16. Well, guys, what's the square root of 16? 4, that's right. We have here the square root of 18x to the 4th. Well, 9 and x to the 4th can come out, but what gets left? 2. So 6 times 4, I get 24. I get 5 times 3, because the square root of 9 is 3. The square root of x to the 4th is x squared. So we have our root 2. So I get 24 plus, well, 5 times 3 is 15. X squared root 2. Now guess what? These aren't like terms. I don't have 24 root 2, and I definitely don't have a 24x squared root 2. So they're not alike. I can't combine them any further. Let's look at the next one. Can I simplify negative 3 times the square root of 5x? Nope. That is already in simplest form. Can I simplify the square root of 125x? Yep, I can actually pull out 25, and what's left over is 5x. So I get negative 3 times the square root of 5x plus 4. The square root of 25 is 5. What do we have here? Negative 3 times the square root of 5x plus 20 times the square root of 5x. What do we get? 17 times the square root of 5x. Hopefully that helps you guys get this. We got 2 left. Let's see if we can crank these out. Now, just notice variables get added in here, but the rules don't change. Radicals have to be in the simplest form. They have the same number underneath the radical. The coefficients have to be like, so I can add them or subtract them. So really simple. Let's keep it going. Last but not least, here I get a negative 15 plus, oh, what's 3 times the square root of 25? Oh, that's 3 times 5. That gives me a positive 15. 0. Woot woot. Got that one down right, guys? All right, now on all these, I would say go back, push pause, try them on your own, see if you can come up with the same answer, even if you're struggling with this. But let's simplify these together. All right, square root of 45. Well, 9 can come out. That's a perfect square number. So I get negative 11 times the square root of 9 times the square root of 5 minus 4. What's the square root of 32? Well, that's the square root of 16 times the square root of 2. And then I'm just simplifying. I took the square root of 9, which is 3. 3 times 11, so that's a negative 33 root 5. Square root of 16 is 4. 4 times 4 is 16, so it'll be 16 root 2. All right, guys, that's all we're going to be doing today on your homework is just practicing simplifying the square root of numbers and then adding and subtracting them. So it's just a lot of simplifying and working with those terms. So hopefully this makes a lot of sense to you. And don't be afraid to call me this weekend if you have questions. I know you just took the quiz and then you're having to do this video, so it's not a lot of fun, but I'm sure you guys will do a great job.